This meeting is being recorded.
For section 5.7, we're going to take a look at another notation or another form of drawing chiral centers called Fischer projections. And Fischer projections, these are also used to represent molecules with chiral centers. These are created by a scientist that was studying sugar. So they had multiple chiral centers. So he tried to find a shortcut method to represent these chiral centers in three-dimensional terms. We're used to seeing the wedge and dash notation, which we can easily convert between a Fischer projection to retain that wedge and dash notation, but it might be a little easier to see the three-dimensionality when we place our groups around a chiral center on a wedge and dash, but we can also assume this three-dimensionality with the Fischer projection. So the assumption that we make is that any of the horizontal lines, so these guys here, the OH and the H group, on this compound, these would be coming out of the page towards us. So similar to the wedge, or exactly like the wedge, right, coming out towards us. And then we have our vertical line. So that would be our ethyl and methyl substituents here. These will be going into the page like the dashes that we see over here on the right. So that is how we can kind of translate between a Fischer projection and what we're used to seeing, the wedge and dash notation for chiral centers. So again, these are most useful when we're drawing molecules that would have multiple chiral centers. So we see here this sugar, the first sugar, is shown to have two chiral centers. So this group here, or this carbon here, and then this carbon here. These will both be chiral centers. Now we have three chiral centers. So all of these dots will be that. And then in the last compound, we see these four chiral centers. So it's a little easier to keep track of our structure, and it's easier to draw the chiral centers if we just use this like crisscross line pattern than it is, it's more time consuming, right, to have to draw those wedges and dashes. So it's also, I think, a little easier to assess whether or not we have enantiomers or diastereomers, the stereoisomeric relationship. So we can see here we have four different isomers shown for the same compound. And if we were to place these first two next to one another, we could see that they are a non-superposable mirror image of one another. So these would be enantiomers. And then if we were to place these two stereoisomers next to one another, we would see that they are diastereomers. And then, of course, we would have the mirror image reflection of this compound. We'll just draw in the H's and the Brs. So we could have another, if we had that fourth compound shown, we would see another pair of enantiomers. So that's why Fischer projections can be useful when we have these multiple chiral centers. You can quickly assess if we have enantiomers or diastereomers. So we practice this briefly during our labs, and you should definitely know this for the next exam as well.